Chapter 8, problem number 48. A block slides down a curved frictionless track and then up an inclined plane as shown in figure P848. The coefficient of kinetic friction between the block and the incline is μk. Use energy methods to show that the maximum height reached by the block is y equals h over 1 plus μk cotangent theta. First, the givens. I've reproduced the diagram for the problem below. We'll say that h is the initial height of the object on the right side of the ramp. Y is the final height of the object on the left side of the diagram. Theta is the angle of incline of the ramp on the left. μk is the coefficient of friction between the block and the ramp on the left. Note that friction only starts once the block has reached the base of the ramp and is frictionless on the downward incline. M is the mass of the object, and g is the constant acceleration due to gravity. From this information, find y in terms of the other variables and constants. We know that the total energy of the system must be conserved due to the conservation of energy principle. Therefore, E initial is equal to E final. E initial is equal to mgh, the initial gravitational potential energy of the object. E final is equal to mgy, the final gravitational potential energy object, plus the energy lost due to friction as the block travels from the right side of the screen to the left. Since we have formulas for both potential energies of the object at both the initial and starting points, now we must find a formula for the energy lost due to friction. Here I have reproduced the ramp from the left side of the diagram. As the block travels up the ramp, gravity pushes it against the ramp surface. The normal force of the block on the ramp is equal to mg cosine theta, where m is mass, g is gravity, and cosine theta is the angle of the ramp. We know that friction is equal to μk times the normal force. Therefore, friction is equal to μk mg cosine theta. We know the force of friction, but we don't know the distance across which it is applied. Since work is equal to force times distance, we need to find the distance the block travels up the ramp. We know that the height of the ramp that the block travels to is y, and the angle that the ramp is theta. Since this is a right triangle, we know sine theta is equal to y over d, where d is the hypotenuse of the ramp. Rearranging, we find that the hypotenuse that the block travels across is equal to y over sine theta. Work done by friction is equal to force times distance. Therefore, work equals μk mg cosine theta times y over sine theta. Combining these two terms, we find that work equals μk ymg cotangent theta. Now we plug this back into our original energy formula. mgh equals mgy plus μk ymg cotangent theta. Now that we have this equation, we must solve for y. The first thing we have to do is divide both sides by mg. Once we do this, we find that mg factors out, leaving us with h equals y plus μk y cotangent theta. Next, factor out y on the right-hand side, giving you h equals y parentheses 1 plus μk cotangent theta. Then, dividing the left side by 1 plus μk cotangent theta, we find that y equals h over 1 plus μk cotangent theta. Looking back at our original problem, we find that the equation we have is the same as the equation we were meant to find. Therefore, we have finished this problem.